Okay, we just got done proving that one of your identities works, the sum and difference identities. Now, this isn't the sum and difference identity, but it's one of them. Sine of 2 theta. Can you find it on a sheet? Again, in my dream world, we'd have time to just memorize them because it would be a lot faster. I have it memorized. What is it? Sine, yeah, 2x and 2 theta would come out the same. 2 sine x, or theta in this case, cosine theta. Now, do you get that this side is the one we're going to actually manipulate? So I mean, it's not illegal for me to think about what I'm aiming towards, but do you get I can't technically manipulate both sides? I'm just trying to see what's my goal. My goal is to turn this into that. So if I don't know what my goal is, I have very little chance of actually achieving my goal, right? Okay, so now, if I just multiply this all out, it's not going to automatically turn into that. It'll take a little bit of extra steps, but multiplying it all out is a great way to start. So everybody, take this, multiply it out, and don't just say, well, isn't it just cosine squared and sine squared? No. No. Remember, when you have something squared like that, you have a middle term. All right. I'm going to pause for a minute while you multiply that puppy out. Both of you guys do it separately, but you can get help from the kid next to you. Okay, let's see how you did. Hopefully, you knew how to do first, outside, inside, last. And then in this case, I'm going to just do this binomial expansion, I guess you could say. Cosine, it's going to be squared. Then the outside and the inside would make 2 sine theta, cosine theta. Now, could you reverse that and say cosine sine? Sure, that'd be fine. And then the last would make sine squared theta. There. Now, what can you notice that could simplify this and get us closer to the goal? Sir?
Cosine squared plus sine squared.
Yeah, it's that one and that one, even though they're not right next to each other, but I can put them next to each other, and they equal 1. And therefore, I have now 1 plus 2 sine theta cosine theta. And that's why we went and looked this up ahead of time so that we could know that's what that is. That is what that is. So I can say then 1 plus sine of 2 theta, because this is that. And then I just have to bring it down. All right. I got the same thing on each side. I'm good. Raise your hand if you think you could do that. Okay, good. Now the other side, I want you to give me some nominations from the back side of your sheet of strategies that you think could apply here. There is multiple right answers. The one that is not a right answer right now is if you can factor it, you should, because there's nothing you can factor here. I mean, you can always factor things, but that would make it really complicated instead of better. So who's got a nomination for a strategy? Yes, sir. Conjugates. So you'd multiply the top and bottom by, in this case, what right there? 1 minus tangent. Good. And why is that particularly good? Because it not only gives you this being something cool, it turns into 1 minus tangent squared. The other side, when I do conjugates, will also be the same exact thing. It'll give you a common denominator, wouldn't it? All right. So could you have used replace 1 creatively? Yes, but it probably wouldn't have got the answer real fast. All right. Now, what's my goal? Tangent of 2 theta. Do you think it's just going to pop out as tangent of 2 theta at the end? Nope. You got to know what the heck tangent of 2 theta is. Go look on the sheet right now. Try to find what is tangent of 2 theta. Find it on your sheet. It's near the end. I think it's bottom right. Ask random person to read it to me. Find tangent of 2 theta. All right. It's row 6, last person. What is it? 2 tangent theta over 1 minus tangent squared theta. Do you get also why conjugates was particularly smart in this case then? It turned this into 1 minus tangent squared, which is what we wanted for our denominator. All right. So I can't actually mess with this left side, but at least I know what it should kind of look like when I'm done. And at the end, it'll be tangent of 2 theta equals tangent of 2 theta, which we just figured out what that was. 2 tangent theta over 1 minus tangent squared theta. All right. I don't need you to finish that one. Just wanted to talk about it briefly. All right. Next. Here's one I want you to actually do with your partner. Ready? This tells you 2 triangles have been placed in different quadrants. The black line there at the top is going to tell you where alpha is. It's in a triangle in one of the quadrants. You figure out where. The green writing tells you where beta is in a totally different triangle. Then, once you've got your 2 triangles all drawn and all the sides are labeled, you won't know the angles. It'll bother some of you. It's okay. You don't need to know the angles, because at the end, what you need to answer is, what is cosine of alpha plus beta? That's different than the one we just proved. What we just proved earlier was cosine of alpha minus beta, but you don't need to prove this. You just need to tell me, what is that? Well, you can look it up on your sheet. In fact, would you please do that right now? Look up cosine of alpha plus beta. It'll have A's and B's, but you can translate for me. Yes, sir. Cosine alpha. Cosine beta. Minus. Notice this is the opposite sign from that. Okay, keep going. Sine, was that alpha or beta first? Sine alpha and sine beta. Okay, so to do this, I obviously need to know what cosine of alpha is. I didn't tell you that. I told you what sine of alpha was. That actually will come in handy. 12/13 goes right there, right? Because sine of alpha is going to be asked for later. But I need to find cosine of alpha. Well, once you've got your triangles all drawn, it'll be easy to find cosine of alpha. Notice, we don't even need the angle. We don't even need to know the angle. We just need to know cosine of the angle. All right, so draw me a triangle for this one. Draw me a triangle for this one. Once you've got them all drawn and labeled, it'll be easy to finish the deal. Your final answer will be a big fraction. All right, I'm going to pause while you give that a try. Okay, I'm going to get you through this thing real quick. Raise your hand if you are done already with this one. Okay, good. I'm going to just double check you here and see if you did it right. So first of all, sine is positive. That's the first thing I see when I look at this. If all students take calc sine is positive up in those two, so it can't be here and it can't be there. All right, next, I think where is tangent negative? Because that's what this means. Where is tangent negative? Well, it's not here because all of them are positive there. So how many of you drew this in the right quadrant? Okay, good. Then cosine is adjacent over hypotenuse. Adjacent side is, no, I'm doing the sine one, sorry. Sine is opposite over hypotenuse, so opposite is 12, hypotenuse is 13. Hopefully remember the 5, 12, 13, but that's got to be a negative 5 because of where we are, right? Okay, then that was my alpha triangle. Now let's go over and do the beta triangle. For B, it's somewhere in there. Where is cosine positive? All students take calc. Cosine's positive in the 2 right ones, so I'm crossing those off. Now I'm left with only 2 quadrants to pick from, and this one even says it's between here, which is 3 pi over 2, and here, which is 2 pi. So it had to be in this zone, can't be there. So how many of you drew your triangle in the proper quadrant for that one? Okay, good. Then cosine is adjacent 3, hypotenuse 5. Oh, 3, 4, 5. Another Pythagorean, what are they called? Triple. Pythagorean triple. And there's a negative missing right there. So final answer. I'm going to scroll down so that I can take the numbers from up in here and put them down into this big formula here. All right. Cosine of alpha. Well, here's alpha. Cosine of that angle is adjacent over hypotenuse is negative 5/13 times cosine of beta. I go over here to get the beta triangle. Cosine is adjacent over hypotenuse, so it would be 3/5 minus, bringing down the formula, sine of alpha. Sine over here is opposite over hypotenuse, 12/13 times sine of beta. Here's my beta. Sine is opposite over hypotenuse, negative 4/5. every single time, by the nature of this formula, you will have a common denominator automatically. 13 times 5 and 13 times 5. Isn't that nice? You don't have to like rearrange it and get a common denominator. All right, so that ends up being, what is that, 65? I think it's 65. Okay, so the denominators are 65s. And did you notice there were two negatives in this? And so we're really adding them. And then this is negative 15 plus positive 48. And that nets out to be a positive, what is it, 33, I think? There we go. How many of you got all the way to the very end and got that answer? Sweet. That's more than I expected. All right, good. So now, this is the part where you guys together conquer these two questions as your quiz. But wait, I got to show you what your homework is for tonight. You might want to take your iPad out so you can cross off the ones you don't have to do. So let's go look at the homework. And I want to warn you, I haven't graded homework in a while, and I really need to put one in the grade book. So I'm very likely to take homework scores tomorrow. I know, you never know when I'm going to or not, but I'm trying to make it reasonable. I'm cutting a lot out of this homework, but you really need to do it tonight. If you don't do homework during this week and then expect to do well on one of your hardest tests, it's not going to work. All right, so first off, this you would normally have to do 3 parts. I'm cutting off 2/3 of it by saying you don't have to do those parts. So this is just like the problem we just did on the board. There's our 12-minute warning where we'd normally be just doing homework the rest of the hour. But got to get you this little quiz. All right, so cross off those two. Next, you're going to cross off these two and only do the tangent of 2 theta, which again, you looked up on the sheet even earlier today. And you don't have to do problem 56 here. Crossing that one off too. So it's only this problem and only do tangent of 2 theta for it. So you're going to make yourself a nice little triangle. All right. Then this one is a good common denominator slash using, what is that word again? Starts with a C? Conjugates. I think you should do one more of those. This one. All right. And then that's it. You can skip the whole rest of the assignment. Okay? All right. I think that keeps it very reasonably sized. But the rest of the hour is going to be this little in-class quiz. So that's all I have for you for your video for today.